Hello everyone, welcome to my channel Content Hub. Today I am going to explain about the double hashing operations. That is, we were going to use the insertion, means how to insert the element in the hash table using using the double hashing. It means that if no collision occurs, simply we insert the element. If collision occur, then how we'll apply the double hashing and insert the element in the hash table. Similar like that, we'll explain about that searching using the double hashing how we'll search the element, and deletion also. So that I'm going to explain in this video. So first operation is that insertion operation. That first I'm going to explain that how do you insert an element using the double hashing in my hash table. So it's almost I have explained the linear probing and quadratic probing. That's also the similar way, but the difference is a small variation in all these collision resolution technique, and that a small resolution variation is helping you to resolve so many problem like linear probing was having the primary clustering, quadratic is having secondary clustering problem, and double hashing is resolving all these because of it is using the concept of the second hashing. Now we'll see that the name is saying the double probing. So what will we do here? We'll use two hash function. We'll use here two hash function. So here I have taken two hash. Now I am going to insert the 11 in my table. I am going to insert 11 in my table. So first I will pass here 11. I am going to pass the 11, and then I am going to calculate index using the first hash function, and then also I will calculate the index using the second hash function. So I have calculated two values, HK key and H key 1. I calculated. Now I am going to check what using HK boy. I am using the first hash function. Whatever the value I got it, that index I will going to check in my table. H table of whatever the index 11 and table size is 10. So we will get that index value is 1. So hash table first index is we'll check that. Suppose this is already filled, this some element is already given in my table. This element is already given in my table. Now we'll check that first index is free. No, the first index is not free. Then what will you do? Come to the else part. Come to the else part. In that you have I value is 1 and I is less than table size. Table size is 10. So 1 is less than 10. Yes, condition true. Come to the index. How will you calculate the index? Index will be the H key is what? 1. First index, hash function index value is 1 plus I value is also 1 into the second hash function, whatever using the second hash function, whatever the value you calculated. So if you are going to calculate 11th value using the second hash function, so 2 into 11, 22 plus 1, 23 modulus 10. If you do that, you will get the 3, right? So 1 plus 3 into 1. So 1 plus 3 into 1, 3 into 1 is 3 plus 1, 4 modulus table size. If you do that, you will get the index is what? 4. You will get the index value is 4. Here you will get the index value is 4. HK value is what? HK value is you are getting that 1, and HK1 value you are getting that 3, and I value is what? 1, right? So here I 3 into 1, you will get that 3 value, and plus 1 4 and modulus 10. So what value you are going to get? 4. Now check that this condition is telling you to check that fourth index is free. Yes, this is free. Then what will you do? A hash table of that index, store the 11 value. So go and store 11 at where? At fourth index. So 11 is going to store at fourth index and break, because you are inserting the single element. So simply insert and come out, right? So here I have inserted the single element, and if a space was there, it is stored, right? If a space was there, he got that place, and there 11 is stored. Sometimes what happened, your table was completely full, your table is already filled, and I'll tell you that insert the element. On that time what happened, this condition is also fail, this condition also fail, this else part is also going to fail, not else part. This for loop also going to fail. If this is also fail, then come to the here. It means that it will check that I equal to table size. It means that this I is incremented, then I reach to that table size. If it is table size, it will tell you that your table is full, you cannot insert the new element. So this is all about the double hashing insertion in a hash table. My next operation is the searching. How will you search an element using the double hashing in your hash table? Suppose a hash function is given to you and you are going to search an element. Hash table is having already some elements are there, and now you are going to search the element. So here I am going to search 50 and 45 using double hashing, right? So I have taken the hash function h1 I have taken and h2 I have taken, right? Now I'm going to now I'm going to search the 50. Is 50 is there in my table or not? So I'm going to search the 50. I'll come here, I'll calculate an index of using the first index. So if I'm going to calculate index of using first index, I will get the value is what? 0. 50 modulus 10, I'll do that. I will get the value is 0. I will also calculate HK key 1 also here only. So 50 into 2, 100 plus 1, 101 modulus 10. If you do, you will get that what? 1. 101 modulus, if you do that, 10 you do that, 10 you do that, what will you get? You will get value is 1, right? Now come here, you check that the 0th value is free. Sorry, no, is 0th value equal to 50? Means whatever the 0th index value is 70. Is 70 equal to 50? No, condition fail. Then come to the else part. Then what will you do? Here you use double hashing, and in double hashing what will you do? The first HK value is 0. So 0, and second HK value you are getting that 1. So 0 plus 1 into I value is what? Also 1. So 1 into 1, 1 plus 0, we will get that 1 modulus table size. So what value will you get here? 1 you will get that. You will get the 1, and check that this condition will tell you the hash table first index value equal to 50. Go and check that first index is equal to 50. No, this is not 50. Then increment the I value. Increment the I value. So now what will you do? HK value is still 0, and now I become 2, and 2 into HK1 value is what? HK1 here, this is HK1. HK1 value is now 2. HK1 value is, sorry, HK1 now, HK1 value is 1 only. I become 2. So 2 plus 0 and do modulus, you will get the 2. Check that is second index is free. No, that's not free. Then what will you do? I is incremented by 1. I become 3. So 3 into 1 plus 0 modulus table size. If you do, you will get the third index. Check that is third index is having 50. No, third index is also not having 50. Then what will you do? You will do that what? The I is incremented by 1, that become 4. That become 4. So 0 plus 4 into 1. 0 plus 4 into 1 and modulus table size. If you do, what will you get? 4. Here you will get the 4, and modulus, if you do that table size, then you will get the 4. Check that fourth index is equal to 50. Yes, this is true. Now you can say that you print that is the 50 is found in the hash table, and you break that. Now you break it, means you come out from the loop, right? So you come out from the loop. Now what will you do? Suppose I am going to search the element 45, and that 45 is not in my hash table. Then what will you how the process will happen? So in that case, in 45 that case, what it will happen? First of all, you pass the 45 here, then you calculate the HK value of using 45 HK value. So you will get the value is 5. You will get here HK is 5. You will get here HK is 5, and HK1 is that 45 into 2 90, 90 plus 1 91, modulus 10 if you do, you will get that 1. HK1 value is also 1 here, right? Then you see, then you, what will you do? Go check that fifth index. Is fifth index equal to 45? Has table fifth index equal to 45? No, this is not there. Then what will you do? Come to the else part. Come to the else part. I is now 1. I is now 1. Then what will you do? Calculate the index. HK value is what? 5. 5 plus I is 1 into HK value is also, HK1 is also 1. Right? So 5 plus 1 into 1. How much it is? 6. 6 modulus 10. What value you will get? 6. Go and check that. Is 6 is having value? Is 6 is having any value? No, 6 is not having value, is 45. Then I is incremented. I became now 2. Then check that HK value is 5 plus I become 2. 2 into its key value is 1. So 2 into 1. 5 plus 2 into 1. Then what will you get? That 7. 7 modulus table size. Check that. Is 7th is having 45? No, not having. This will tell you that there is no 45 at 7th index. Now I incremented by 1. I become now 3. So 5 plus 3 into 1 modulus 10 you do, you will get 8. And check that each 8 index is having 45. No, not having. Then I is incremented by 1. I become 4. So HK value is 5 plus I is 4 into HK1 is 1. So now you will get that 9 modulus table size. Check that 9th is free. No, not free. Then I become now what? Now I become 5. Using that 5, calculate the table size. Then after you will get the 0th index. Then you will check the first index. Like that you will going to increment I till 9. I will go in this condition will going to run till 1 to 9. And afterward this condition will going to fail. And then you reach here. When you reach here it will tell you that I equal to table size. Yes, I become now 9 here, sorry 10. After this loop you will get that I is incremented. Now I become 10 and I equal to table size. Yes, now it table size. Then you can say that element is not there in your hash table because you have checked complete hash table. You have checked one by one. Is it free? Is it free according to the index you calculated? Sorry, not free. Is element available or not available? Like that, you search that, and afterward you say check that element is not there in your table. So this is the complete searching method. Next is that deletion one. That's very much important. In the deletion, what will you do? Same thing. First you have to search the element, and then what will you do? The searched element. We are performing deletion here, na? Then we just replace with the null value. So if you replace with the null value, it will tell that that element is not there, right? So what will you do here in the deletion? First of all you calculate the index. First of all calculate the index, means you search the element. Same process just now I have explained about the searching. Suppose you are going to searching the 50. So using the previous procedure that I have explained, using that previous procedure, suppose you found the 50. Suppose you found the 50. Suppose here it's saying that each table of the value equal to 50. Yes, right? So suppose you got that 50, that is in your table. Now what will you do? You say that hash table of that index, the fifth index. While deleting the 50, what will you do? Simply you put, instead of 50, you put the null value. You put the null value, right? And you say that 50 is deleted. That's all. If it is no element there, then I is incremented. This loop is iterated till table size minus 1. And if you come out from this loop, na I is incremented and I become 10. If you are come out from this loop, na I became 10 because table size is 10. Now if you see that 10 table I equal to table size, the condition become true, and then it will tell you that deletion not possible. Why so? Because that element is not in your table. If it is element is not table, how will you delete it? That's not possible. So this case is nothing but this case is when it will tell you that if element not found in your table, this case will going to execute, right? If element is found and collision occur, then else part is going to run. If no collision there, then if part is run. So there is a three thing is here. One is if part, another is the else part, and third one is that what? Third one is that if your table free. You can say that if part is that no collision, else part is having collision, and another if is for if table is free. So that's all about the double hashing operations, insertion, deletion and searching that I have explained here, and that's important one. That's why I have explained. That's all about the double hashing operation. Thank you for watching my video.